It's Farrar's repaired angle drive. Yay! This is what Farrar's gears looked like before the angle drive was reassembled. It's modified worm gear, modified spur gear. The worm gear I modified, like I said in the other video. I filled the barrel full of JB weld and then sank a 1/8 inch square post in it while the JB weld was drying. So he now has a perfectly square receiver that runs the entire length of the barrel. The barrel actually extends a little bit below the beginning of the gear teeth. And to give the JB weld a little something to sink its teeth into, I left these crimps alone. These crimps actually did protrude into the barrel. These crimps here did not protrude into the barrel. They were basically just marks on the outside of it. His lower speedometer cable was only being gripped on two sides. So I drilled these two through so the JB weld could protrude through and give something JB weld to sink its teeth into. And then at 90-degree intervals, I drilled two more holes. So you got 1, 2, 3, 4 holes that the JB weld is grabbing a hold of. And this is what his lower speedometer cable looks like. All they do is they just crimp a square shape onto the otherwise round cable. And it's just a hair less than 1/8 of an inch. And it just slips right in, has a nice snug fit. That's his worm gear. Now the spur gear, I put a square receiver in it. So he now can use a replaceable spindle cable. And if the spindle cable ever needs to be replaced, he doesn't have to take the angle drive off. All he has to do is just pull the old one out and put a new one in. And this here is his new spindle cable here. I used bronze wire rope because it's easier for me to solder to bronze than it is for me to solder to steel. This is about a 100-pound load rated rope. If you were to use a steel wire rope, it would be about 500 pounds load rated, 1/8 inch. But 100 pounds is a bazillion times heavier duty than the original, so it's not going to give him any problems. This here is the end that goes into the spur gear. Just slips in like that. In fact, let me see if I can't assemble the angle drive with one hand. This should be a treat. There's his worm gear. There's his spur gear. There's his replaceable spindle cable. And then his dust cap. Like I said, this is a true 1/8 hole, and the crimps that they put in the factory cables are actually a hair less than 1/8 of an inch. That's why sometimes they're woggly. This here is actually a very snug fit. Laying down so I can't get it there. There we go. There's his new angle drive. That's what it looked like before it got put on the car. Apparently, Farrar has been asked, why don't you replace the spindle cable, the flexible spindle cable, with a solid metal spindle rod? I had forgotten that is what caused the bushing to wear out on my original Smith Industries angle drive. When I bought my car way back in 2002, it had about 4,500 miles on it, and it had a Smith Industries angle drive, most likely original from the factory. Well, not long after I bought it, probably within the first year of ownership, the spindle cable unwound on me, turned into spaghetti. So I replaced the spindle cable with a rod. I tapped threads into the spur gear, into the barrel of the spur gear, and then put a square end on it to go into the dust cap. And the threads were not 100% perpendicular to the spur gear teeth. They were close. I mean, if they were off, it would have been like a factor of half a degree or something. But they were off just enough that the rod, the inflexible rod, exerted pressure on the spur gear's bushing as the wheel rotated. And with time, it eventually wore that bushing oblong to the point where the spur gear would drop away from the worm gear. The teeth were fine. The problem wasn't the teeth. The problem was that they wouldn't intermesh with each other anymore. So that's why I would not recommend an inflexible rod. Or if you're going to put an inflexible rod through your spindle, make sure that it's 100% perpendicular to the gear teeth. And you got to remember now, the angle drive itself is a little bit woggly in that great big nut. So I don't know if even that would prevent some unnatural stresses on the bushing for the spur gear. One other thing I forgot to show you yesterday when I was showing you the gears that go inside Farrar's angle drive is the spindle cables themselves, the construction of the spindle cables themselves. This here is Farrar's original spindle cable, and the way it's constructed, you've got 2 layers of windings around a central core, and you've got 5 wires in each layer, but they're parallel to each other. You've got 10 wires, but they don't overlap each other. They lie next to each other, other than the fact that the 2 layers overlap each other. But that's what makes up his original cable. Now this here is the wire rope that makes up his current spindle cable. And it's a totally different construction methodology. Well, first of all, you also have more wires. This is either 6x6 or 7x7. I have to count all the wires. It's either 36 or 49 wires. And the way it's made is 6 or 7 wires are wound together, and then 6 or 7 bundles of those wound together wires make up the final rope. So it's either 6 windings of 6 or 7 windings of 7. I'll have to count them to see whether this is 6x6 or 7x7. But there's a lot more wire that makes up his current spindle cable than the original one. And it's significantly heavier duty. I mean, this is the way the wire rope that you would get in like a hoist or a come-along or something like that. I mean, that's how it's made. They're multiple windings of multiple windings, and it's just a much heavier duty construction. Like I said, this is load rated wire rope, 100-pound load rated, just due to the fact that brass is softer than steel. But this exact same cable here, if it was made out of steel, would be a 500-pound cable, either 500 or 750, depending on whether it's a 6x6 or a 7x7.